All right, so last section we're going to look at this week is 1.2. And what we're going to look at is a little bit more with the calculator, okay, how we can graph on it. And I might show you something that we haven't done yet, okay, on the calculator. So the first thing they go over in this section is just kind of a general problem-solving strategy. Not necessarily even for math, but just any kind of problem that in life you need to figure out. So the first step when you're trying to figure out how to solve something is you've got to figure out what information do I have to work with that I know. Okay, what is it that they're telling me? And what is it that I'm asked to find? Okay, so you kind of break down the information into two categories. What can we use that we already know, what are we given? And what is it that I have to try to figure out? Okay, the second step is then to kind of come up with a plan, okay, some type of method that you're going to use to solve the problem. Now, let's say I gave you a word problem, right? Something like, you've got a swimming pool and the dimensions of the swimming pool are like 50 feet by 40 feet, big rectangular pool. And you're going to put like a sidewalk around it. And I give you all this information in writing. When you have a word problem, what is it helpful to do that makes it easier to think about all the information that they've given you? Rather than having it all written in sentences, it's easier if you take all that information and make a
picture.
Yeah, make a picture. All right. So making a picture is an approach we're going to use a lot. When we get to trig, you might have phrases like in a triangle, the opposite side is 10, the adjacent side is 6. Find the hypotenuse. Sometimes it's easier just to make a picture so you can see, what's opposite, what's adjacent. Visualize it. Another method sometimes that comes up is making like a list. So if I said to you, I want you to take the letters A, B, and C and arrange them all the different ways that you can. Some people might start in like an alphabetical order, just kind of systematically listing everything out. And what do you got? C, A, B, C, A, no, C, B, A. I think that's all of them. All right, so I just made a list of all the different ways that I can arrange the letters A, B, and C. What could become kind of time-consuming, though, about making a list? What could happen to your list? This one had 6 things in it, but your list could get what? It could get longer. Yeah, it could get really long. So like if I said to you to take every letter in the alphabet and tell me every single way you can arrange every single letter, every possible order. I mean, there might be millions or billions of ways. So we don't want to make a list. So lists are okay for maybe short things, not for long things. Another thing that'll come up a lot is making an equation. A lot of times drawing a picture and then making an equation kind of go together. Sometimes the equation is a formula that's already well known, right? If we were dealing with a right triangle, and I said this side's 3, this side's 6, I want you to find the hypotenuse. Well, there's a well-known formula that you can use to find the length of the hypotenuse if you know the other 2 sides in a right triangle. Does anyone remember the name of the formula? Yep.
Pythagorean theorem.
Yeah, you can use the Pythagorean theorem. So in that case, the equation that you need to solve for this problem is a formula that's already known. Other times, it's a formula you need to figure out. Okay? It's not like a common formula. It's a formula that's special to that problem. So then that involves a little bit more thinking about how to set the formula up. All right, so once you try, break down the information they give you, come up with a plan of what method you're going to use, now you actually have to carry out that plan. Okay? So that's the last step. try to solve your problem using the method that you decided on in step 2. And sometimes you try to start to solve a problem and you realize the method you picked wasn't a good method. Okay? Or maybe you had the right method, like you tried to set up an equation, but the equation you set up, it just doesn't work. So you might have to go back and try a different equation. All right, so any questions on that? Okay. So we're going to look at a problem. This particular problem doesn't have a formula that's already well known. It's not like we can just use Pythagorean theorem to solve it or something. It's going to be a formula we have to come up with that's special to this problem. And the formula that we're going to come up with needs to represent this situation. So there's a company that charges $15 to rent a car, and then they charge 20 cents for every mile that you drive the car. One thing you don't have to decide on is the method that you're going to use in this problem to get going. They tell you, write an equation. So that's what we need to do. This problem doesn't really lend itself to a picture at this point. Maybe in a little bit, okay, but not yet. All right, so first thing is this problem is going to have 2 variables in it, 2 different variables. Does anybody have a guess what one of the variables is going to be? Yep?
The number of miles.
Right. The number of miles is going to be one of your variables. That's going to be called our independent variable because the number of miles is going to control the other variable. What's the other variable in this problem? Yep.
The total cost.
Right, the total cost. And that's our y variable, and that's called our dependent variable. So this is the dependent variable. This one is the independent. And the way you can remember y is dependent is if you kind of read it out loud. The total cost depends on the number of miles you drive. Cost is dependent on miles driven. Not the other way around. You wouldn't say the miles you drive depends on the cost. If you need to rent a car and go somewhere, you're going to drive however far you need to drive, and the cost is going to be whatever it's going to come out to. Okay. So the cost is dependent on the miles. Sometimes we might use different letters like C and M, like cost and miles, but in this case, if they're using X and Y, we're probably going to do something with graphing in a little bit. That's why they picked those 2. Okay, so our formula is going to start out y equals. Does anybody have a guess at what the expression would be on the other side? Yeah?
20 cents or 0.02x or 0.2x
0.2x.
plus 15.
Yep. Plus 15. You could put 0.2x, that's fine. It's the same as 0.2x. Yeah. So that's the equation that represents this situation. Okay, any question on that? Where x is the number of miles and y is the cost. All right, so let's use that equation now and figure out the cost for driving the car 50 miles. What would I do with the 50 and the formula that I have up above to figure out the cost for driving 50 miles? Yes, Dylan.
You plug 50 into x.
Yeah, you're going to take the 50 and plug it in for x. So you get 0.2 times 50 plus 15. Okay, so 0.2 times 50, that's going to give me 10. and I'm going to add 15, and I get 25, and I should put a label on that. What label do I need to put on the 25? Dollars, right? Not miles. That's $25. Any question on how we got $25? All right, now the next one, 100 miles. Since it's double the distance, can I just double the cost and say, all right, it's going to cost $50? No? Why not?
Well, because you add the, oh, you could like double like the 10, but you can't double like the 15 on it.
Yeah, you don't want to, you're going to double the cost for the mileage part,
Yeah.
but you don't want to double the cost for the 15, because that 15, that's just like a one-time fee. That doesn't double. Okay, so when we do this one, 0.2 times 100, well, 0.2 times 100, that's going to give me 20. And 20 plus 15 is going to give me $35. Yep. So in both of those equations, there wasn't really any algebra involved. Okay. The variable that we wanted by itself, cost, was already by itself the whole time. Okay. So this was more just arithmetic, plugging in a number and just evaluating the answer. Any question on that one? All right, so now, this equation that we set up, okay, that's called the algebraic representation of the problem. Okay, if somebody were to come in right now and look at the board and see that equation, 0.2, you could put 0.20, that's the same thing. Y equals 0.2x plus 15. They have no idea that this is about renting a car. And you pay $15 up front, and then you pay 20 cents a mile. When you write down the algebraic representation, you've kind of taken all the details about the word problem, and you've removed that and turned it into just a pure math equation. To know what these numbers mean, you'd have to go back and read the word problem again. So, in the book, if you see something that says, like, find an algebraic representation of the problem, it means just write an equation that represents what's going on. Okay. And if you weren't sure what that meant on a test, I would clarify that. Okay. Directions on a test, I would definitely clarify. Buttons, like on Edge Elastic, if you're not sure, like, what a button does, I could explain what the button does. But if you have to know what button to click, like to get the question right, like how to use like a calculator, say, I can't tell you like how to raise something to the second power, like on the calculator. If I taught that during the week, you need to know the button to raise it to the second power. I can't point to it and say, oh, the button's right there. Okay. If an error comes up on the calculator that has nothing to do with what we taught, I would fix that for you. All right. So there's lots of different things that can happen. So if it's not related to what we learned, you're not responsible for figuring out why your calculator is not working. All right. So now let's take the same example, and let's suppose that Sarah was charged $50 to rent the car. Now I want to figure out how many miles. Let's, bless you. I don't know if that was the right response. I want to figure out how many miles she drove. What's different about this question compared to the last two questions? This one's a little different. Yeah?
You already have the answer.
Okay, we already have the answer for, what did they give me? What is it that they gave me here that's different than what they gave me before? Chad?
They give us the total cost.
We already have the total cost. So what's the answer they want me to find this time? Yeah?
The number of miles.
They want me to find the number of miles. So when we look back at the formula, where is that 50?
Y.
Yeah, that's going to go where the y is. Then we have to get the variable by itself. So this is more of an algebra problem now. So let's fill in 50 for y. Algebra is not the only way to solve it. It's one way, and that's how we'll do it first. So fill in 50 for y. Yeah, 0.20x, and then plus 15. All right. Ileana, what would be my first step to get x by itself?
Subtract 15 on both sides.
Yep. So we're going to subtract 15 on both sides. Okay, so that cancels out. And Cadence, 50 minus 15 is going to give me
45.
45. All right. So I got 45 equals 0.20x. And Felicity, my last step.
35.
Oh, 35. Yeah, it'll be 35. Thanks. Yeah, 35 equals 0.20x. And now my last step.
Divide by 0.20.
Yep. So we can divide each side. Again, 0.2, 0.20. That's the same thing. So divide by 0.2. 0. And let's see what that comes out to. 35 divided by 0.2. Okay, 175. And that's x. But what is that? 175, is it dollars? Yep. It's miles. Yep. So 175 miles. So in this case, solving it with algebra, I mean, it was maybe 2 steps. Minus the 15, divide by 0.2, you're done. So the algebra approach isn't really, it's not that bad. But any questions on the steps that we did there? Let's try a different approach. So let's try doing it on the calculator. So there'll be some questions that we try to solve, and maybe we just want to double check our answer, or maybe the equation is something that's so complicated to solve we don't know how to do it with algebra. We can try it on the calculator. Okay, so to do it on the calculator, I want to go back to what we had in that box right there. 50 equals 0.20x plus 15. Okay, once we turn the calculator on, that's the button in the lower left, you're going to go all the way to the top left, press y equals. Okay, if you have something that's in there, what's the button I can press to get rid of that?
Clear.
Yep, press clear. It's right down on the right-hand side. It's right below the arrows. So everyone should be at a screen that looks exactly like that. Anybody have something different, or they're not sure how to get to that screen? Okay. So now, you notice you got y1 through, and if you scroll down, I think there's a y0. So you get 10 different things that you can plug into. Okay, we're going to need to use 2 of them. What's on the left? We're going to take what's on the left, and we're going to plug that into where it says y1. We're going to take what's on the right, and we're going to plug that in where it says y2. So y1, we're going to make it 50. Press the down arrow. And then y2, we're going to plug in the other side. You could just put 0.2, that's the same thing. 0.2, that's the decimal button, and then the 2 is right above it. Does anyone remember how we get the x? Yep.
Is it the one where it says like right next to alpha?
Yep, right next to alpha, below mode, it says x, t, theta. This button does different things depending on the mode on the calculator, but we're in the mode where it gives you an x. So 0.20x plus 15. Now, when we solved this algebraically, we used opposite operations. We had a plus 15, we did a minus 15. We had a times 0.2, we did a divide by 0.2. Okay, we did algebra. We're not going to do algebra this time. We're going to look at a picture. We're going to look at where the y1 picture and the y2 picture are the same. What do you think that would mean if we draw two different pictures and we're looking for where the pictures are the same? It's kind of a weird way to say it. We would normally say we're going to look for where the two pictures do what? Intersect. Okay, so we're going to draw it and look where they intersect. All right. So let's leave it like that. Whenever we don't know the window to start with, I said yesterday that zoom, which one is the one we use? Yep, we'll do zoom 6. That's negative 10 to 10, negative 10 to 10. Okay, as long as the yellow circle's spinning in the upper right, it's still drawing. And it's done drawing. Okay, so we had this problem yesterday. Where is my picture? It's not there. So it's, where is it then?
15.
It's off the graph.
It's off the graph. Right. This one on the left is a horizontal line. Whenever you type y equals and you put in a number, that's a horizontal line. And it's a horizontal line up how high? What number?
50.
It's at 50. So if we go to our window, which value would I need to make higher so I can see a horizontal line at 50? Yeah?
Y-max.
The y max. And we probably want to make it even a little higher than 50. If you make it 50, it's going to be right on the edge of the screen. If you make it 70, it's going to be a little bit further in from the edge of the screen. Okay, so let's make the y max 70. Let's hit graph. Okay, here's our line at 50. And there's our line that has a y-intercept of 15. And the number in front of x is 0.2. Does anyone remember what you call that number in front of 0.2? It's the slope. So 0.2 is not a very steep slope. So this line's going up very slowly. Okay, I'm looking for where these lines do what? Where they intersect. Okay, I can't see it on the screen. What would I have to make higher in my window so I can see where they intersect? Yeah, the x maps. And we already know the number where they're going to intersect. Okay, we already solved for it. Normally, you don't know that number. Okay, so you just take a guess and you set it higher. Now, the other thing about the window, x is miles. Does negative 10 miles make sense? No, you don't really need to be looking at the negatives in this problem. The smallest number of miles you could drive would be to just not even rent the car, and that'd be 0 miles. So negative miles doesn't make sense. Y is the price that you pay to rent it. Are you going to pay a negative price to rent the car? No. So not always, but sometimes negatives don't make sense in your word problem. So what we're focusing on now is really quadrant 1. Just positive x's and positive y's. But we're not high enough yet with the x's. So you might guess like 100. Try that. That's better. You can definitely see the line is getting closer. But how high do we have to go?
75.
Yeah, we're going to go to 175. But if you do 175, it's going to be just on the edge. It's going to be hard to see. So I might do a little extra. Do like 200, and that'll be perfect. So there's your horizontal line, and there's your other line. Right? It's close to the edge, but it's not like right on the edge where I can't see it. All right, so now you should have a picture that looks like that. Any question on getting a picture that looks like that? So we can see where the lines cross, but now we need the calculator to tell us, well, what's the answer? Okay. To figure out where these two lines cross, you're going to press the blue button in the upper left that says second, and then you're going to press the button that says trace. So it's second, and that's the calculate. When you do that, you should see that menu. All right, we're going to do options this year. We'll do options 2, 3, 4, and 5. Those are the only ones I'll talk about this year. 6 and 7, that's calculus, so we'll never talk about them. And option 1, I've never had to use really before. So out of options 2, 3, 4, and 5, which one do you think we need? Yep.
Intersect.
Yep, intersect. So you can either go down to 5 and hit enter, or if you just press the number 5, it'll go right to 5. Okay. Once you press option 5, it's going to ask you 3 questions. It's going to ask you, what's the first line on the screen you want to use? What's the second line on the screen you want to use? And it asks you for a guess where you think they cross. All right. I only have 2 lines on the screen. So I just have to tell the calculator to use the blue one and the red one. You might think it would know that because there's only 2, but it doesn't. So my cursor is on the blue one right now. You can pick a point anywhere you want. This point is just to identify which color line we're using. So we're going to use the blue one, hit enter. So now you've told the calculator use the blue one, and we also want to use the red one. Doesn't matter where you put your point. It just has to be anywhere on the red line. Okay. And now it says second curve, hit enter. So now you've told the calculator which 2 lines you want to use. And the last thing is the guess. In this particular problem, the guess doesn't matter. You could hit enter right where it is. Right? But I'll show you why the guess is important in another kind of problem. But if you want to put the guess kind of close to where you think they cross, you can. Again, it will make no difference. And then hit enter one more time. If you did everything right, it should say for the intersection point, x equals 175. All right. So was anyone unable to get intersection x equals 175 to pop up? All right. So that's how you can solve that same problem graphically. Questions on how we did an intersect? So it's always, a lot of times the calculator will always ask you 3 questions when you do an intersect for most of the things we do. Actually everything, I think. When you do a 0, it asks you 3 things, minimum, maximum, 3 things. Yeah, it would always ask you 3 things, so you have to hit enter 3 times. So why does it ask these 3 things? Well, let's say I had something like this. Okay, just watch. You don't have to type that in. All right, how many different lines do I have on the screen now?
3.
Yeah, I've got 3 different lines. If I want to figure out where they cross, I can only find 1 point at a time. So if you want to know all 3 of them, you'd have to do intersect 3 times. So let's say I want to know this point right there. I want to know where the black and the red one cross. So the first thing I have to do is tell the calculator, ignore the blue one this time. We're not using it. So when I do second calc intersect, right now my cursor is on the blue one. If I didn't have color and I couldn't tell by the font, I could just move it to the left and then I can see, okay, it's moving along the blue one. That's not the one I want to use this time. If I press the down arrow, it'll go to one of the different lines. Okay. The red one is one of the ones I want. So pick a point anywhere on the red one. All right, and then it automatically went to the black one. If it didn't, I'd have to press the up or the down arrow till I get to the other one that I want. Okay, so I pick the red one, pick a point somewhere on the black one. And this time those 2 mattered. So is there any question why it mattered which 2 lines I picked to find what's circled? If you don't pick those 2 lines, you won't find that spot. You might find a different one. The guess still doesn't matter. You could put, you could put the guess way up here and just hit enter. And I get an answer of 50. Okay, so I just wanted to show you a question where where you're picking the lines matters. I still haven't shown you one where the guess matters. I'm going to show you that one next. Was that your question?
Yeah.
Okay. So when does the guess matter? Well, let's type in something like, well, I'm just going to clear all this out. Let's type in x squared, and then let's type in 5. Okay, and I'm going to do zoom 6. X squared is going to be a parabola, and x equals 5 is a horizontal. Okay, this one is a little different. How many times do the blue curve and the red line cross? Twice. So in terms of picking which lines I want to use to find the intersection, there's only 2. That part doesn't matter. So I do second calc, I do intersect. I want to use the blue one, so pick a point on the blue somewhere. I want to use the red one, so pick a point on the red one. Now the guess. The calculator can only give you one intersection point at a time. If you want the one on the left, you need to move the guess closer to the left. As long as it's just a little bit closer to the left one, it'll find the left one. So even though I'm not right on top of it, if I hit enter right now, it's closer to the left one. That's the one that it jumped to. Okay. If I wanted the intersection point on the right, I got to do the same thing again, but put the guess closer to the right.
What happens if you put exactly in the middle?
I think it would probably just randomly, however it decides, just pick one. Yeah. So like if I put it closer to the right, just a little bit, okay, gives me the one on the right. Now if you put it right in the middle, okay, if I can even get it right in the middle, might not be able to. I would have to get x to be exactly 0, and you can see when I hit the left arrow, it's not going through every number, it's jumping. So I don't know if it's going to land. It might. Yeah, it does. It lands on 0, so when I hit enter, it gave me the right one. I don't know, you might do that, it might give you the left one. I'm not sure exactly how that works. But I do know if you're closer to one than the other with the guess, that's the one it gives you. Okay, so that's when the guess is important. And that's everything you really need to know about intersections on the calculator. Any questions on that? Okay. So we did that. All right, so yeah, last thing. When we do this zooming in and zooming out, okay, to try to see our graph, like the last problem we did, we had to zoom out. Okay, we couldn't see where the two graphs crossed. Once we zoomed out and we could see where they crossed, that's called a complete graph or a complete window. Once you have a window that shows you all of the important things in your graph, that's the window you want to write down. Okay? If something is off the screen, like let's say you're trying to find where they cross, and that point where they cross is off the screen because it's at like 175, it's up really high. If you can't see that point, that is not a complete graph. Okay? You need to be able to see everything that's important in your picture. So what are things that are important? Well, if you're looking for where two graphs cross, the intersection point is something you want to see on the screen. In fact, if it's not on the screen, second calc intersect, I don't think it will work. You have to be able to see it to make it work. Other things that are important might be minimums and maximums. In this case, I can see the bottom of the parabola. So for a parabola, a minimum or a maximum is important. If you had a window like this, I would say now that is not a complete window. You've cut off an important thing about the parabola. You've cut off the minimum. That's not good. Other things that might be important, Maybe where a graph crosses the x-axis, or where it crosses the y-axis. I can see all of those here. And I can see those intersection points. So I would say for these two graphs, that's a good window. I can see everything I need to see. If a question asks you to find a window, all you have to do is write it down. Okay? How many numbers do you have to write down to describe a window? Yeah, it's rectangular. Yeah.
4.
Yeah, you need 4. So what I'm looking for in a window, x min, x max, y min, y max. And you can write it like that if you want. All right, and I think we did that one yesterday. Let's try a different one. Let's try x minus 2, x plus 3, x minus 6. All in parentheses, just exactly like that. I'm going to type that in. Okay, so we don't want anything cut off. Now, that doesn't mean you're going to be able to see the whole graph. Like if you draw a parabola, it's a U shape, but it just keeps going up forever. Well, you're never going to be able to see, the end of it because there is no end. Okay, let's put in x plus 3 and x minus 6. Okay, I want to start with the standard window, go back to that, and then we'll adjust it from there. Okay, so make sure when you type it in Y1, it looks just like that. Zoom 6. All right, so I can see that the graph kind of goes up, comes down, goes back up. And I'll give you a hint. You can draw this without lifting your pencil. You could trace this and never have to lift your pencil. So there is part of the graph that's off the screen. So based on the standard window, would you say that that's a complete graph? No. What would I need to adjust so I could see this graph better? I'm not looking for the number yet. Just tell me the two things that have to change. Yeah?
The y values.
Yeah, we need to change the y values. We need to look lower and we need to look higher. Now, how much lower and higher do we need to look? Well, we can just keep guessing numbers. Or we can get kind of an idea by using a trick I'm going to show you. Right. If the numbers that are higher and lower were in like the millions, I don't want to spend all day guessing numbers. It may take me like 10 minutes to figure that out. So what I want you to do is press the blue button and then press window. So second window. You should see a screen that looks like that. And I want you to set it up so your two variables, your x and your y, independent and dependent, are exactly like that. If they're both on auto, well, then just highlight ask and hit enter. Okay, so that was under second and then window. Okay, is everyone able to get a screen that looks like that? No? So you press the blue button, and then did you press window? Okay.
Can you go back to the formula, like the y?
Yep. Put that right over there with that. Okay, so once you are at that screen, I want you to press second and then press table. Second, and the button that says graph, and it'll bring you a table that looks like this. You might have numbers already typed in there, you might not. If you press the delete button, it will get rid of the numbers that are typed in there. It's not a big deal if you leave the numbers that are there, but if you don't like them, Press delete and get rid of them. And let's take this line and let's put it about right there. So that's a guess where I think this graph, it's going to do something like this. It's going to come down and go back up. I don't know how low it goes. But I can tell you that the x value, where it's the lowest, is probably around 1, 2, 3, 4, somewhere between 4 and 5. I would say between 4 and 5 is when this graph is going to be down at its lowest. Any question why I picked something between 4 and 5? I'm just looking at the picture. I'm just kind of eyeballing it. I'm not doing anything like mathematical. Yeah.
It's kind of in the middle.
Yeah, it's like kind of in the middle right there. So it's probably, yeah, right around there. So on your table, type in 4 and hit enter. Okay. Let's type in a little bit more. Let's type 4.2. Negative 28. Let's type in 4.5. Negative 28. Let's type in 5. All right, now we're heading back up. So I'd say around negative 30 might be a good value to put in. Let's do the same thing one more time. Let's just look at where it goes up. I don't know, maybe somewhere in there. It's going to go up and come back down. Where does it look like that line is on the x-axis now? Between what two numbers? Yeah?
Negative 1 and 0.
Yeah, somewhere between negative 1 and 0. So let's try negative 1. Okay, we're up at 42 for the y value. And I don't have to use this table. I could plug in negative 1 by hand and do it out. So negative 1 minus 2, negative 1 plus 3, negative 1 minus 6. So plug negative 1 in for x and then multiply it all out. But the table's quicker. It does it for you.
It's not letting me do it. It's on the table.
It's not letting you delete, and when you press second window, yours looks just like that.
Yeah. Oh, it did.
And then once you highlight it, just hit enter, so it'll move it over to ask. Yep, so you gotta press the down arrow. Yep, and now, there you go. And hit enter, now it's all set. Yeah, if it's not letting you delete numbers in the table, it's because those two things are not set the right way. All right, so that's at negative 1. Let's try like negative 0.5. All right, that's actually a little bit lower. 0. All right, that's coming down. It's even lower. So I would say maybe like 50. So let's set the y max at 50. It gives me a little extra. We'll set the y min at negative 30. Y max at 50. Remember, for the negative, make sure you use the button below the 3. Now, when we hit graph, if you put in those numbers for your window, hopefully it doesn't go off the screen. Perfect. A little close on the bottom, but it's okay. It doesn't go off the screen. And there's your graph. All right, so how would you write it down? Well, one way you can write this down. X, y min, y max. We didn't change the x's. We used the standard window. That was negative 10 to 10. The y min, I think, was negative 30. Y max, 50. So when you're asked to write a window, you can do it like that. Or, I think I showed you this yesterday, you could write negative 10 to 10 by, so it's like dimensions, negative 10 to 10 by negative 30 to 50. The first two numbers you write are always the low and the high for the x's, and it has to be low, comma, high in that order. The next two numbers you write are for the y's, and they have to be low, comma, high, minimum, comma, maximum. Both of these answers are correct. Any questions on finding a complete graph in that situation? And there isn't always one right answer. Like if you put the y max at 60, I would say that's fine. If you put the y min at negative 40, that would probably be fine. But if you did something like this, you put your y max at 50,000, do you think I would say that that's a complete graph? No, I can't. Now I can't see anything. I have no idea what's happening. It looks like a pretty flat line. And it kind of looks like there's like a thicker part right here. But I have no idea that it's that curve shape now. So it's a balance between finding a number that's too small and you cut something off the screen versus a number that's way too big. Right. And that just takes a little practice. All right, any questions on that? Okay, so we got done a little bit early because, again, this was a pretty short section. I would say most days we'll probably go at least another 10, 12 minutes. But you got over 15 minutes left. You can use that time to start the homework. And there aren't that many questions, so you probably could finish it. 6 through 10, all, 18 and 29. Okay, so as you saw last night, there was definitely more questions than this. That last night's probably more typical. There'll be more questions, but that's just where we're going to stop for today. So let me put a list of test topics on the board. Okay, so that's everything that's on the test. So the distance and midpoint formulas, graphing inequalities on a number line. So the test program, it's pretty easy. You have 4 different buttons you can click, and depending on which one you click, you might have a box that looks like this, another one that looks like this, one that looks like this, and one that looks like would look like that. So if you want to have, say, a closed circle shaded to the left, you would click. You'd click this one, and then you click on the number line, and it'll put a closed circle, and it'll put an arrow pointing left. Okay, but I can help you with that on the test, but it just gives you buttons. Evaluating expressions, so that's simplifying, like doing arithmetic with absolute value problems. Graphing points, so you'll be able to just click with your mouse where you want to put a point. You'll have a grid on the screen. You just have to put the point in the right spot. Identifying the different properties we talked about yesterday. So I'm going to ask you something about like the associative, commutative, distributive identity. That was another one. Graphing on the calculator and being able to set a window. So we talked about that today. I'm going to give you an XY table. And from that table, I'm going to have you like either make a picture, or I'll give you different pictures and say which one of these is the correct graph if you were to use the points in this table to make the picture. And I'll give you like 5 or 6 points. The next one will be creating an equation from a word problem, kind of like the rent-a-car one. And then you're going to have to plug into that equation to solve. Like you might have to, if it was the rent-a-car problem, you might have to plug in a number of miles and find a cost. Or plug in a cost and find the number of miles. But that'll be 14 questions, and that's everything that's on the test.